Let's review some examples from chapter 3. All right, so let's go ahead and start with a simple example that's a function notation. And this week we're looking at some of the characteristics of the different functions. So just to remind you that a function has to pass the vertical line test. Okay, so if you have a graph, let's just say, something like that, that would pass the vertical line test because anywhere I draw a vertical line, it will just pass through once. However, if I graph, let's just say something like that, that would not pass the vertical line test, right? We would get more than one y value. So here we're looking at the characteristics of some different functions. So this notation just means f of x. That means that x is our independent variable. So we are going to substitute in values for x. And as we change the values of x, the output, the y values, will change, of course. So in this case, it just means substitute in 3 for x. So we're going to do that. And that will give us 7. Okay? Okay, there we go. All right, so pretty simple. We're just substituting in. So then we would say that f of 3 is 7. Okay, now we're going to go ahead and look over here. This is f of negative 3. That means that negative 3 is the x value. So we're going to substitute that in here. And when you do that, one thing just to be careful is the negative 3 goes in place of the x. So it's going to get squared, the whole thing. So negative 3 squared. And then, of course, the minus 5. So negative 3 squared is a positive 9. And positive 9 minus 5 is 4. So f of negative 3 is 4. Okay, be very careful. Just to give you a little warning here. If you type in negative 3 squared and you do not put the negative 3 in parentheses, your calculator is going to say that that is negative 9 because it's going to square the 3 and then it's going to make that value negative. So just keep in mind in this example, the negative 3 gets squared. So put it in parentheses that reminds you to square the negative 3, not just the 3. Okay, so I just wanted to point that out. So be careful when you put it into your calculator. Okay. All right, here we have a purchase being made with $20 worth of merchandise, and they're going to include 7% sales tax or tack that on at the end. So you got your $20 worth of merchandise, adding sales tax to it, and we're going to figure out what that total would be. So we could complete it in 2 steps. For instance, we could first just calculate what the tax is. So that would be 20 times 0.07 for the 7%. Okay. And when we do that, we'll get $1.40. So then the total would be 20 plus the tax. $21.40. Pretty simple. Okay. Another way we could set it up, and some of you might have been thinking of it this way, is, sorry, we're going to go ahead and just calculate the total in one step. So that would be 20, but instead of just multiplying by 0.07, we can multiply by 1.07. What that does is the 1 takes care of the original amount, and then the 7% takes care of the tax. So when we multiply 20 times 1.07, it adds the 7% onto the 20, and we would automatically get our answer. But you could do it in the 2 steps either way. Okay, I want to just go over about representing some of these notations on like number lines. We've got set builder notation, which is this one with the brackets. Okay, set builder notation or set notation. We've got the number line, which we got to taste, kind of got to play around with that a little bit last week. And then interval notation. And so that's introduced this week. So let's just go through and see what this notation would look like in those other forms. So this, the set builder, you just read it as the set of x, okay, that's establishing the variable right there. That vertical line just means such that. So we're saying the set of x such that x is less than -1 or x is greater than or equal to 1. So we've got x going in two different directions. It could be going less than -1 or greater than or equal to 1. So let's go ahead and put that on a number line first. All right, so I'm going to put -1 here, 0 and 1, just putting those values on. Okay, so x is less than -1. That's an open circle because it's not or equal to. I'm going to draw it above just so we can see it. And less than means shade to the left. Greater than or equal to 1, that would be a closed circle. And greater than, we would draw to the right. So that's the number line. But then if we want the interval notation, we would have to have two different intervals. Okay, let's take care of the less than -1. So this is interval. Well, x is less than -1. It means from all the way -infinity to -1 with a parenthesis. Parenthesis is used just like an open circle is. So if it's less than or greater than, we were going to put in a parenthesis. Infinity always gets a parenthesis because we really can't reach it. A bracket indicates that we actually will reach that number and include that number. So you're only going to put a bracket if it's greater than or equal to or less than or equal to. So x is less than -1. That means all the numbers from -infinity to -1, but not including -1. Notice I didn't put a bracket. And then you still put that union symbol. Okay, and then x is greater than or equal to 1. So that's a bracket at 1. And if we're going to keep on going greater, then we're going to go all the way and keep going to infinity. So notice I have the bracket at 1 because it's or equal to, and a parenthesis at less than -1. So the brackets follow the number line. That's why I do like the bracket note, or the the interval notation follows that number line. I like the interval notation, especially when we're graphing. All right, let's look over here. Let's get another one in here. Number line first. Okay. All right, so let's say I want to graph. This is saying x includes all the numbers from -2, including -2, because it's or equal to, all the way up to 2, but not including 2. So that means we're going to have a filled in or closed circle at -2, open circle at +2, and then we would shade in between. So that's the number line representation of that set. And then if I want to show it in interval notation, I would set it up as bracket -2, because that's or equal to, comma, we always put a comma in between, and then 2, but we would put a parenthesis because 2 is not included. So -2 to 2, including -2, and notice it's similar to what the number line looks like. All right, let's go ahead and look at another one. Okay, so I've got x is greater than -3. So I'm just going to put -3 on there. I'll put 0 over here. So x is greater than -3, open circle, greater than, shade to the right. Okay, in a similar way, we're going to get the interval. So the interval notation, -3 with a parenthesis because it's open, so -3. And then it's going to keep on going, just like the arrows indicating, so does infinity. And on the one on the right here, x is greater than or equal to 0. Okay, I'll just put 0 there. Greater than or equal to, that's a closed circle. Greater than, shade to the right. And the interval for that one, since it's or equal to, and we have a closed or filled in circle, that would be 0. And since we're going to the right, infinity. And keep in mind that an interval has to go from left to right. Think of it like left to right on a number line. It's got to go small to large. So you'll never put infinity to 0. Okay, you'll never put -3 to infinity. Right? And I just wanted to, so like if you notice here, just to point out, the negative infinity to -1, notice negative infinity comes first. Positive infinity should always go on the right side. Negative infinity would go on the left side. All right, now domain and range. Okay, domain, you read that. That is the x's, and that we would read left to right. And range, that is bottom to top. Okay, so let's look at number 8. Okay, so left to right, what's the furthest? Remember, this is x's is domain, y's range. So the furthest to the left, the x value is -3. Notice it's open, so that's a parenthesis, -3. And then if I look over here, it's going, remember, I'm not looking up or down, I'm just going over to the right, and it's going to stop at 1. If you look at 1, there is a point down here. So 1 has a y value, so we're going to count it. It's filled in. So that's going to be 1 with a bracket. That is the domain. Okay, the range, we're going to look at it in a similar way, but we're going to go bottom to top. And we are looking at the y values. So remember, domain, x values, range, y values. Okay, so what's my lowest y value? Well, it's -4. Okay, and it is touching here and a filled in circle. Even if this had been open, because it's touching over here, we would count it. So that's going to be -4 with a bracket. Go up to the top. Well, it's going all the way up to the x-axis, which is 0, right? The y value is 0 here. However, it's open on the left side, like here, that's open, but it is touching here. So there is an actual value at 0, 0. So it does touch at y equals 0, so we do include it. So even if there's a hole at one place on the x-axis, because it does touch, we include it. All right, now let's go ahead and look at 9. This is a line. Okay, let's write the domain. Once again, left to right, and you're only looking at the x values. So it looks like 1, 2, 3, 4, 5, 6, 7. So it looks like we're over here. This point is -7. 1, 2, 3, -3. So we'll use those values. And this one is 1, 2, 3, 4. 1, 2, 5, 1. Okay, and so I'm just writing the ordered pairs. Those aren't intervals, so they're all parentheses because it's a point. Okay, so let's put the domain. So the domain, x to x, so -7, and it is filled in, so -7 to 5, parenthesis because it's open. And then let's take care of the range. Range, bottom to top, and use the y values. -3, because it's filled in, gets a bracket. 1, it's open, so that means the line is going up to 5, 1, but it's stopping just before that. So it's stopping somewhere like maybe like 4.99999 and 0.99999. So it's getting really, really close, but it's actually not going to touch at that point. And one last one here. Let's look at this parabola. Okay, this vertex, right, that's our vertex. That is 0, 2. And we're going up to infinity. Okay, we're going to put arrows here. If they wanted us to stop, they'd have to give us endpoints, okay? All right, so let's see. Domain. Okay, I'm going from my x, which is 0, all the way up to infinity. Oops, I was thinking of range, not domain. Let's keep that pink. Domain is left to right. There is no restriction, so that is negative infinity to infinity, all real numbers. Okay, I could put, this graph, it's going to continue opening up to the left and right. It's, opening up kind of slowly, but it will. There's no end point. It's going to keep on going. And then the range, okay, that's what I was getting excited about. So the range, we're going to use that y value of 2, and it's going to go up to infinity. So notice parabola, it has no restriction left to right, no endpoints left to right, so we just say negative infinity to infinity. The range is the one that's controlled by that vertex because it will not go any lower than y equals 2. So that's going to be the starting value for our range. Okay, I just wanted to make sure I covered some of the key concepts, so I hope you found this helpful.